Okay, so here's some worked out answers to this practice test. I'm looking at the first one. I'm seeing a radical. I'm seeing some stuff underneath the radical, and I'm seeing an x squared dx outside of the radical. So that's telling me I might want to let u be the x cubed, the part that's the x cubed. So I'm going to let the u be everything that's underneath the radical. Alright, so then I take the derivative of that. The derivative of 7 is 0. So I'm going to get 12x squared dx. And I'm seeing an x squared, I'm seeing a dx, so I'm going to divide by 1/12 to get that out of the way. So then I can replace, so I can go back to my integral. I can replace the x squared and the dx with my du, my 1/12 du. I'm going to pull the 1/12 outside. And everything underneath the radical gets replaced with the u. Now to find the antiderivative of this, I'm going to treat that square root of u as u to the 1/2. Add 1 to it. So that gives me u to the 3/2. I'm going to divide by 3/2, which is the same thing as multiplying by 2/3. So I've got the 1/12. I've got the 2/3. I've got u, which is 7 plus 4x cubed, all raised to the 3/2 power, and then plus c, of course. And this cleans up to be 1/18 times 7 plus 4x cubed, all raised to the 3/2 plus c. Okay? If you're watching this, you'll notice that that's different than what I had on the printed answer sheet that I provided you. Okay, so let's look at problem number 2. Which of these represents the fundamental theorem of calculus? Well, I know when I'm substituting it's becoming definite integrals, so I wanted to tell you there's two parts to the fundamental theorem of calculus. And one of them is that if I have the integral, and this is the one that applies here, if I have the integral, a definite integral, the fundamental theorem of calculus part, what is it, part 2? I don't remember now. It's one of the two parts. Doesn't really matter which part, as long as you know there's two of them. That says you can find the antiderivative of the function, then substitute and then evaluate it. So the antiderivative of f of x, and evaluate that from a to b. Some of you seem reluctant to use this vertical line, and then you write the two bounds there. Please start doing that. It'll help you out. It'll communicate to the readers what you're doing. But this is the fundamental theorem of calculus, one part of it. Okay, the other part of the fundamental theorem of calculus, actually I'm going to replace this with u. So f of t dt, if you take the derivative of this integral, is you just replace, you take the derivative, you replace whatever variables there is there, so that would become f of u, and then you're going to take the derivative of that thing, so du dx, I'm sorry, I wrote t, so I put x down here, I've got to use x here. So if this is just x, it's going to be, you know, you don't have to worry about this part, it'll just be f of x. There's a problem later on that you got to worry about this, okay? And there's one in the exam that you got to worry about like that. So, but anyway, so this is the fundamental theorem of calculus. We take the indefinite integral and we make it a definite integral with variables, and we do that evaluation. So if we go back and look at that problem now, okay, which one of these choices replaces? See, there's no bounds here, and then they write some bounds, and now we know that. Once, as soon as we make it a definite integral, we're going to have to evaluate it. And I'm seeing 0 to x, so that's right. The trouble with this one, it's x to 0. We always like the lower bound on the bottom. We also like to have a number here, so not a variable. And this one, I don't know what they're doing here. So the correct answer here is D, and that's just recognizing that we're turning this indefinite integral into a definite integral. Okay, knowing which one to choose. All right, so question, let's clear that if I can. Okay, the third question. We got to evaluate that. Let's see. Didn't I scratch out 3? Now that I'm looking at it, let's do 4. Okay. No, actually, we did 3. We did 3. So it'd be nice here. Just a minute. Grabbed a copy of the test I printed up for you that's blacked out. All right. So we did do 3. I'm seeing an ln x, and I'm seeing to the 5th. I think this is a prime candidate for a u substitution. Okay, so if you think about u substitutions, I see a 1 over x. I see an ln x raised to the 5th power, and I see a dx. Well, I know the derivative of ln x is 1 over x, so that might be a good way to go. Is let's say u equals ln x, du equals 1 over x dx. So then I can replace, it'll be u to the 5th, and then the 1 over x dx gets replaced with du. And we're going to integrate that. So that becomes, we're going to add 1 to the 5, make it 6, divide by the 6. So I'm going to get 1/6 of something raised to the 6th power plus c. Well, that something is our u, which is ln x. And that's the antiderivative of that. Pretty easy. Okay. Next question. We have to evaluate that definite integral. Here, I won't bother going back to the test. So we got to evaluate from 0 to pi over 2 e to the sine x cosine x dx. Well, if this were e to the u, that would be an easy function to integrate. So what we're going to do is, here's my work here. I'm going to say u equals sine x. So du equals cosine x dx, and then I'm seeing there's a cosine x dx. So I can replace e to the u du, but then the thing that you have to remember to do is, because this is a definite integral, we're going to replace those bounds by substituting those into whatever we said our u was. Well, the sine of pi over 2 is 1. The sine of 0 is 0. So I'm going to replace those with 0 and 1. The antiderivative of e to the u is e to the u, and I'm going to evaluate that from 0 to 1. So that's e to the 1 minus e to the 0. E to the 0 is 1, so it's just e minus 1. Okay. So now, let's see. Next question is, we have to use integration by parts to evaluate. I'm going to go grab that one. Okay, so they're telling us to use integration by parts. You've got to remember the integration by parts formula, which is you have u times v minus the integral of v times du. And then you got to keep doing this until you're done. Well, you also have to remember that Lipit mnemonic that'll help you remember what to substitute in. Logarithms inverse trig. I see an inverse trig function there. So I'm going to let u be the arc cosine of 2x, and I'm going to let dv be dx. Well, if the antiderivative of dx is just x, that's easy. The derivative of that inverse trig function, though, is you've got to remember our triangles. Okay, so let's go to a new sheet. So I'm trying to find the derivative of y equals arc cosine of 2x. Well, so I'm going to take the cosine of both sides. And then I'm going to draw a triangle. You guys remember this, I'm sure, I'm hoping. So let's see, cosine adjacent over hypotenuse, which makes this the square root of 1 minus 4x squared. Okay, so the derivative of this is negative sine y dy dx equals 2. So if I divide both sides by the negative sine of y, that's the same as having the negative cosecant of y. So the cosecant is hypotenuse over opposite. So that tells me it's negative 2 over, that should be plus, right? Negative 2 over the square root of 1 minus 4x squared. So we're going to remember that and come back to our other page there. It was negative 2, right? Here, I'm just looking for my work. Negative 2 over the square root of 1 minus 4x squared. Okay, then we're going to apply that formula. So I'm going to multiply these two. And then I've got to multiply these two to get the other part of it that's in back of the new integral sign. So it's going to be x arc cosine of 2x minus the integral. Now minus a negative 2 is going to make that plus. I'm also going to pull that 2 out because it's a constant, and x over the square root of 1 minus 4x squared dx. This should have a dx with it. Okay, so now I've got to integrate this part. Well, I'm seeing, get that back here, I'm seeing a radical with an x squared underneath it and an x dx on top. I think this is the prime u substitution situation again. So I'm going to let u be that expression. I'm going to take the derivative of that expression and get the negative 1/8 or the negative 8 out of there. So I'm seeing that substitution's nice. So I've got a negative 1/8 I'm going to pull out. 2 times negative 1/8 is negative 1/4 times the integral of 1 over the square root of u du. Well, that's u to the negative 1/2. I'm going to add 1, divide by the 1/2, which is the same thing as multiplying by 2. So I get negative 1/4 times 2 u to the 1/2. And u we said was 1 minus 4x squared. And I also know that 2 and that 4 will cancel out. So negative 1/2 times the square root of 1 minus 4x squared. I need my original x arc cosine of 2x, and I need a plus c. Not too bad, not too bad. Let's do the next problem. Actually, I'm going to stop this video and make it on, put in a new one.